Howdy, my name is Haley and I'm an engineering student at the University of Colorado Boulder studying creative technology and design. Today's lesson is all about pendulums. We will swing through topics like inertia, Newton's first law of motion, and other important physics concepts. Have you ever been on a pirate ship ride at an amusement park or fair? To get this ride started, a powerful motor pushes the ship upward. But get this, after the ride starts, the motor doesn't need to do any more work. The ship just keeps swinging back and forth on its own. Why do you think this is? Well, it turns out that after the motor gives the ship an initial push, a special force called inertia keeps it in motion. But wait, why doesn't the ride fly all the way around in a circle from the motor's power? Good question. The force of gravity comes into play here, pulling the ride back down on each end as it swings. Throughout the ride, the forces of motion keep the ship moving, unless it's stopped by an outside force. In this case, the force that slows down the ride to a stop at the end is a set of brakes. Yarg, land ho! So, the pirate ship ride is an example of a giant pendulum. That being said, let's explore what a pendulum is in its most basic form. A pendulum is made up of a mass, called a bob, that dangles from the end of a rod or string. With this configuration, the bob is able to move freely. Did you know that anything that swings under its own weight is a pendulum? This includes common objects, like a tetherball, playground swing, and grandfather clock. Even your own legs behave like pendulums. You swing them back and forth to walk or run at top speed. In fact, the time it takes for your legs to move back and forth depends on their length. That's why taller people can move their legs slowly and still walk faster than shorter people that are walking briskly. There are a few types of pendulums that exist. First is a simple pendulum, which only moves back and forth. A swing set is a good example of this pendulum type. Another type of pendulum is called a spherical pendulum, where the bob is able to move in a circular motion. An example of this is the tetherball we just talked about. Since the forces of inertia, friction, and gravity are essential to pendulums and how they stay in motion, let's explore them further. More than 300 years ago, an Englishman named Sir Isaac Newton described the natural behavior of motion and gravity in the world around us. He coined these behaviors as the 3 universal laws of motion. To understand pendulums, we'll zero in on Newton's first law of motion, which states that an object in motion stays in motion. Consequently, the law also states that an object at rest stays at rest, unless acted upon by an outside force. Newton's first law is the backbone of inertia. Have you ever been ice skating before? Have you noticed that you'll keep sliding on the ice unless you drag your feet or crash into the wall? Or on a playground swing, have you ever noticed that you'll keep swinging unless you take action to slow yourself down? These are all due to Newton's first law of motion coming into play. A lot of the time, objects that are moving will sometimes come to a standstill on their own, like a ball rolling that eventually slows down to a stop. This is the result of a force called friction, which is otherwise known as a resistance to motion. As it turns out, pendulums work so well because they move through the air, which has very little friction. Furthermore, one of the greatest forces acting on the world around us is the force of gravity. Gravity keeps objects grounded to Earth. In other words, it's what pulls me back down toward the ground after I jump instead of shooting me off into space. In the case of the pendulum, gravity pulls the bob downward, while inertia keeps the bob in motion. In the late 1500s, Galileo Galilei studied the pendulum and mathematically described its motion with an equation. In doing so, he unearthed that the only factor that greatly affects the swing of a pendulum is the length of its string. That's so cool! Engineers use pendulums when designing lots of things, from amusement park rides to clocks. Engineers who study earthquakes design equipment such as seismographs, which use a pendulum to measure earthquakes with a system known as the Richter magnitude scale. Also, using pendulum mathematics, engineers determine the best way to design buildings that can sway with the force of earthquakes or windstorms, rather than crumbling under the pressure. Thanks for keeping us safe, pendulums! Finally, engineers have helped us to tell time. They've harnessed a pendulum's constant oscillation period to regulate the movement of a clock, which keeps track of every second of the day at an extremely accurate level. How can you get into the swing of things by leveraging the power of pendulums? Can you design your own amusement park ride using the forces of inertia and gravity? Whee! Or can you make an art piece at home using a pendulum? What kinds of cool patterns can you create with the Bob's motion? Pendulums can be found all around us. They are a prime example of how us humans harness the powerful forces of nature to improve our lives. That's all for today. Thanks for watching this video, and I'll see you next time. Check out the full lesson on the Teach Engineering website. Then, apply what you learned about pendulums in our associated activity, Swinging with Style.